This is Powell, and in this video I'm going to show you how to graph a quadratic equation. Now there's three ways a quadratic equation can be written. It can be written in standard form, vertex form, and an intercept form. We're going to go over all three, but in this video we're going to go over standard form specifically. So a standard form quadratic equation is of the form y equals ax squared plus bx plus c, where a, b, and c are integers and a cannot be 0. Specifically, we're going to look at the equation y equals x squared plus 2x minus 3, where a equals 1, b equals 2, and c equals negative 3. Now I'm going to show you how I like to approach graphing these equations. Obviously, there's more than one way to do this, but this is just the way I generally do this. Now the first thing we have to find when we are graphing something in standard form is what's called the axis of symmetry. Now you do this when you're looking at an equation in standard form mostly. And the way you calculate it is x equals negative b over 2a. Now the axis of symmetry serves two purposes. The purpose we're most interested in when graphing is the fact that the axis of symmetry is the x-coordinate for the vertex. The vertex being the lowest or highest point of the parabola, depending on how it's oriented. The other purpose of the axis of symmetry, and we're only going to see this after we graph it, is it's the line of reflectional symmetry of a parabola. And as I said, we're going to see that after we graph it. We're going to see that if we were to draw a line down the middle of the parabola, it would go through x equals negative b over 2a. So for this particular equation, the equation for our axis of symmetry is negative b, which is 2, divided by 2 times a, which is 1. That simplifies to negative 2 divided by 2, or negative 1. Now because that's the x-coordinate for our vertex, we're going to put that in the very center of our table. So we're going to make a table of values to get some xy coordinates. In case you want to know what app I'm using on my iPad, I'm using Notability because it's very good to move stuff around when it's not where I want it to be. And that's going to go right in the center as our x-coordinate for our vertex. The vertex I always like to put in the center, and you're going to see why when we look at all of our y-coordinates. Now we're going to pick a couple integers to the left and to the right of negative 1. So to the left we have negative 2, negative 3. And to the right we have my favorite two numbers to plug into equations 0 and 1. I'm going to start with plugging in 0. And when we plug in 0 to our original, the two terms with x go away and we're left with negative 3. And then we're going to plug in 1 into our equation, and we're going to get 1 plus 1 minus 3, or 0. And then we're going to plug in negative 1 to get the vertex, and we plug in negative 1 and we get negative 4. Now the reason I like to pick the vertex as the middle, and we're going to take advantage of the fact that a parabola is symmetrical, is because all the values to the immediate left are going to be the same as all the y values to the immediate right. So I know that if y is negative 3 when x equals 0, y is negative 3 when x equals negative 2. You can check that, of course, if you'd like. And the same thing, when y is 0 when x equals 1, I know that y is going to be 0 when x equals negative 3. And that only, of course, works if you pick numbers that are immediately to the left and to the right. So now that we have our xy coordinates, let's graph them. I always like to draw the graph after I get my table of values so I know how to scale things and I know what quadrants I need and don't need. So for instance, since most of our y values are negative, I don't need much of quadrants 1 or 2. And also, none of our values are that ridiculous, so we don't have to scale or go by 2's or anything. So negative 3, 0, negative 2, negative 3, negative 1, negative 4, 0, -3, and 1, 0. And we get our parabola. And we get to take a look at the other definition for our axis of symmetry, and that's the line of reflectional symmetry, which if I draw it in, notice if I folded the parabola along this line, everything would match up on the left and right. And this is x equals -1, which is our axis of symmetry. So there's a lot that's connected between the axis of symmetry and the vertex. And that's pretty much it. So if you like this video, please feel free to comment below on any topics you'd like me to cover in the future. And most importantly, share this with someone that you think might benefit from knowing how to graph quadratics. Thank you very much.